What's going on, everybody? Welcome to the Lightning Talks. My name is Drew Rogers. I am a DevOps engineer and sysadmin at Chariot Solutions. So today I'm talking about scaling in Kubernetes. And I use the phrase getting creative, and kind of like, why do I use that phrase? It's because scaling is kind of boring. It's CPU and memory increases, something increases, CPU memory decreases, and then something decreases. And that's been pretty much it for the past 15, 20 years. So before VMs, if we needed to scale up our app, if we needed to give it more CPU and memory, we just gave the machine more CPU and memory. Or we would take a server, slide it into a new rack, set it up, and there you go, you just scaled up. And in the VM era, with really fast networking and very expensive SANs, our hypervisors would use technology like vMotion, and then we would be scaling up VMs between physical nodes. Or just forget hardware altogether and use EC2 and auto-scaling groups, and then we could scale VMs in the cloud. And to see what that looks like, oh, it's actually running already. Okay. This is a locus test that I'm running on an auto-scaling group with scaling based on CPU utilization. And notice that it took the ASG about 6 minutes to even start the VM scaling process. And even when the VMs are scaling, it takes a while for them to initialize and the host to boot, and then for the VMs to actually become available to the load balancer. So kind of slow, but none of this matters because we don't use VMs anymore. We use Docker, container, and Kubernetes, or other orchestration, but Kubernetes. So let's see what scaling looks like in Kubernetes. So Kubernetes can scale nodes in managed groups, but we're not really going to talk about that now. We're going to focus on horizontal pod auto-scaling, or HPA. So here's a pretty basic HPA manifest. This tells us how many pods we want, the minimum amount of pods we want in our scaling group, the maximum number of pods, and here is the trigger. This is what the metric we want triggering scaling events. In this case, it's the average CPU utilization for all running pods. So basically, if it's above 50, scale up. If it goes below that, scale back down. So what does this look like for the old locus test? So if you notice, on the left-hand side, the pods are scaling up much more quickly than the ASG. It's taking seconds instead of minutes. So they're making themselves available to the load balancer much more quickly than the ASG. So that's great, but we're still using CPU metrics. And it tends not to be enough in Kubernetes just to use CPU and memory. We want to start using defined metrics that define the service that we're trying to scale. So Kubernetes introduced an external metric API service a while ago. And with this, now we could start fetching metrics from external sources like Datadog, CloudWatch, Prometheus. And then with these external metrics, we could use operators like Kata to enable event-driven scaling. So now we choose how we could scale instead of just waiting for the pods to ramp up CPU, and then we'll see if that actually makes a difference or not. So in our last Nginx example, instead of using CPU and memory utilization, we choose the metric we use to trigger our scaling using a Kata scaled object. So for instance, we're using an ingress controller request to scale up one pod for every 50 requests that come in. So if 400 requests comes in, we scale up 8 pods. So here's the same locus test, but in this time we're using a total number of requests to scale our pods instead of CPU, which you can see on the right side. That's the Prometheus metric we're using to scale, not CPU. So this is great, but Nginx scaling is boring. So let's start thinking out of the box. So say you have a web app that hardly gets any traffic. It normally only needs like one pod to handle all the requests. Since the link to the web app is in your company's Twitter profile, you want to make sure this deployment is ready if you ever go viral. So luckily, we have our Twitter mentions in Prometheus and very aggressive scale-up behavior. So in this scenario, for every 50 mentions we get in our Twitter profile, we scale up 10 pods instead of just the default one. So we're ready for the Twitter hate to come and and bombard our whatever service we're running. But the thing is, instead of waiting for the onslaught of requests coming in and then scaling, we're scaling first, predicting the onslaught of requests coming in, not after. So again, we're predicting the scaling this time instead of just waiting for it. Another example is, say you're a Twitch streamer and you want to have a service that that turns on, or that's turned off when you're not streaming, and then turns itself on when you start streaming. And as you're streaming and as active users come in, your service scales up just according to your active users. So in this case, the ideal replica count equaling 0 will ensure that our deployment is dormant when we're not streaming. And then we also have current active users in Prometheus that will scale one pod every 100 active users. So in this example, I have a single pod fetching active user data from one of my Twitch buddies that was helping me out with this example. And notice that the deployment was 0 when he's not streaming, and when he starts streaming, the pods start immediately. And as users start trickling in, you see pods slowly scaling up. So why would a Twitch streamer want a service like this? Well, some Twitch streamers direct their live audience to a service running outside of Twitch for some sort of user engagement. So having a scaled object makes sense for this, because the more active users you have coming into your stream, the more potential live users are going to use the service. And also, having a scaled object like this will be ready for an unusual auto-scaling event, meaning maybe this person gets rated by the most famous Twitch streamer, and all that person's live audience gets dumped into this person's stream, and they go from 600 people to 10,000. In that scenario, as long as the max pod is a high number, this scaled object will scale up in that event. 10,000 users, scale up a lot. So again, instead of having the scaling event happen after the influx of users, we're scaling up first, predicting the possible influx of users, which is a great thing in Kubernetes, because you could do it really quickly, and then you could scale down really quickly. Say you scaled up and you don't really get an influx of users. Who cares? Kubernetes will just scale down pretty quickly, depending on how you have your behavior. So I think I'm pretty much over time a lot. So hope this was kind of interesting, but thank you very much, and enjoy your rest of ETA.